So welcome back guys. In this video we will see the remaining sums that were left of this chapter current electricity. So let's look at the remaining sums. The EMF of a cell is balanced by a length of 120 centimeter of potentiometer wire. When the cell is shunted by a resistance of 10 ohms, the balancing length is reduced by 20 centimeter. Find the internal resistance of the cell. So let's write the solution. Now we know when potentiometer is used to find the internal resistance, the formula for the internal resistance is given by R equal to capital R into L1 upon L2 minus 1, where L1 and L2 are the balancing lengths. Now based on the given condition, the length L1 is 120 centimeter. Now when the cell is shunted by the resistance of 10 ohm, the balancing length is reduced by 20 centimeter. That is L2 will be 120 minus 20, which is 100 centimeter. Now these two things can be written in meters as 1.2 meter and this as 1 meter. So let's calculate the internal resistance. So R will be, resistance is given to us as 10 ohms. 10 into 1.2 divided by 1 minus 1, which is 10 into 1.2 minus 1, which is equal to 10 into 0.2, which is 2 ohms. So the internal resistance is 2 ohms. Let's look at the next sum. A potential drop per unit length along a wire is 5 into 10 raised to minus 3 volt per meter. If the EMF of a cell balances against length 216 centimeter of this potentiometer wire, find the EMF of the cell. So let's write the solution. So they have given us the potential gradient K, which is equal to 5 into 10 raised to minus 3 volt per meter, and we need to find out the EMF of the cell. Now the EMF of the cell balances against the length 216 centimeter of this potentiometer wire. So the L is 216 centimeter, but we need to convert it into meter, which will be 2.16 meter. Now we know the formula E equal to K into L. So let's multiply this to calculate the EMF. So 5 into 10 raised to minus 3 into 2.16 volts. Now multiplying these two, we'll get 10.8 into 10 raised to minus 3 volts. So the final answer we'll get it as 0.0108 volts. Let's look at the next sum. The resistance of a potentiometer wire is 8 ohms and its length is 8 meter. A resistance box and a 2-volt battery are connected in series with it. What should be the resistance in the box if it is desired to have a potential drop of 1 microvolt per millimeter? So first of all, let's convert this into SI unit. So K is given to us as 1 microvolt per millimeter. So this can be written as 1 into 10 raised to minus 6 volt upon 10 raised to minus 3 meter, which will be 1 into 10 raised to minus 3 volt per meter. So they have given the resistance of the potentiometer wire R equal to 8 ohms and its length to be 8 meter, and the EMF that they have given to us is E equal to 2 volt, and we need to calculate the resistance in the box, which is nothing but our internal resistance R. So we know the formula for K, which is equal to V by L. Now this thing can be written as ER upon R plus R into L. So this implies our K is 10 raised to minus 3, which is equal to E. E is 2 into resistance is 8 divided by resistance is 8 plus our internal resistance R into length 8 meter. Now 8 get cancelled. Now this thing can be written as 8 plus R equal to 2 divided by 10 raised to minus 3. Now this 10 raised to minus 3, when it goes up, it will become 10 raised to 3. 2 into 10 raised to 3 is 2000. So this is nothing but 2000. So 8 plus R equal to 2000, which implies R equal to 2000 minus 8. So our internal resistance comes out to be 1992 ohms. I hope you understood this sum. Let's look at the next sum. Find the equivalent resistance between the terminal of F and B, that is this point and this point, in the network shown in the figure below. given that the resistance of each resistor is 10 ohms. So this network of resistors each have a resistance of 10 ohms, and we need to calculate the equivalent resistance between these two terminals F and P. Let's suppose the equivalent resistance comes out to be R equivalent. So the equivalent circuit diagram will come to be this thing. Now when you will apply Ohm's law, the R equivalent comes out to be E upon I. So essentially, if you will find the ratio of E upon I, you will find the value of equivalent resistance. So let's try to do that here. So solution, let's apply KVL at loop A, B, H, G, A, that is like this. So applying KVL at A, B, H, G, A, this will give you minus 10 I2 plus 10 I minus I2 plus 10 I1 minus I2 minus 10 I2 equal to 0. So opening the bracket and solving, you will get minus 10 I2 plus 10 I minus 10 I2 plus 10 I1 minus 10 I2 minus 10 I2 equal to 0. Solving this, you will get eventually 1, 2, 3, 4 minus 40 I2 plus 10 I plus 10 I1 equal to 0. Now dividing this with 10, you will get minus 4 I2 plus I plus I1 equal to 0, which implies that, let's write this in terms of I1 equal to 4 I2 minus I. Let's name it at equation 1. Similarly, applying KVL at loop GHFG, you will get minus 10 I1 minus I2 plus 10 I1 I minus I1 plus 10 I minus I1 minus 10 I1 equal to 0. And solving this again, this time you will write this equation in terms of I2. You will get I2 equal to 4 I1 minus 2 I. Let's name it as equation 2. Now what you will do is, you will put the value of I1 that we got in equation 1 into this equation, which will give us I2 equal to 4 into 4 I2 minus I minus 2I, which is equal to 16 I2 minus 4I minus 2I, which is equal to 16 I2 minus 6I, I2 equal to, which implies I2 will be 2 by 5I. Now once we got the value of I2, let's put the value of I2 in equation 1. So I1 was 4 I2 minus I, which will be 4 into 2 by 5 I minus I. Solving this, you will get 8 by 5 I minus I, which will be equal to 3I by 5. So I1 is 3 by 5 I. Now keeping this in mind, keeping the value of I1 and I2 in mind, let's apply again KVL at loop A, B, C, D, E, F, G, A. So we get minus 10 I2 minus 10 I2 plus E. You can refer to this diagram. We are applying the KVL for this loop in anti-clockwise. Minus 10 I2 minus 10 I2 plus E minus 10 I1 equal to 0, which will give you E equal to 10 I1 plus 20 I2. Now let's put the value of I1 and I2. So I1 we got 3 by 5I and I2 we got 2 by 5I. So E will be 10 into 3 by 5I plus 20 into 2 by 5I. So 5 ones are 5 twos are 5 ones are 5 fours are. So E will be equal to 2 threes are 6, so 6I plus 4 twos are 8, 8I. So E is equal to 14I. Now if you look carefully, E upon I is 14. So what we said here, that the ratio of E by I will give you the equivalent resistance, which implies that our equivalence resistance, R equivalent, comparing this equation, is nothing but 14 ohms. This was a pretty lengthy sum. I hope you understood what we did here. Let's look at the last sum of this chapter. Voltmeter has a resistance of 100 ohms. What will be its reading when it is connected across a cell of EMF 2 volt and internal resistance 20 ohms? So solution: the resistance of a voltmeter is given to us as 100 ohms, and we need to calculate the reading in the voltmeter, and the EMF is 2 volt and the internal resistance is 20 ohms. So we know the formula for V, which is equal to E R upon R plus R. So let's put the value: 2 into 100 divided by 100 plus 20. So this will give you 200 by 120. 0 0 cancel. 2 6 are 2, 10 are 2, 3 are 2, 5 are, which will give you 5 by 3 volts. To write it more precisely, we will get V equal to 1.66 volts. So this was the last sum. I hope you understood all the sums that we did in this video. Thank you for watching this video, and if you liked this video, please like, share and subscribe, and comment your feedback regarding the content that we post on this channel. Thank you.